Welcome to today's webinar, Using Panels in FCS Express 5 Flow Cytometry. I'm Kaya Ghosh, an application specialist with Novo software. On the line, we have Sean Burke, who's our product manager, and he'll be happy to answer any questions that you have along the course of the webinar, or we can follow up with you offline later on. So don't be shy about entering those questions in. That's what makes this a great interactive experience. So today we'll be talking about panels. And we'll be covering all these points down here about panels. But first of all, what are panels? Panels are a useful feature that's available in FCS Express 5 and also previous versions of FCS Express that make it easy to establish a complex analysis strategy for a multi-tube experiment. So the panels feature will allow you to reuse your layout the next time you run a similar experiment. So you don't have to recreate the wheel every time you repeat an experiment. So you can just create your panel, load your FCS files into the panel over and over again, however many times you want to redo this experiment, and then watch as your plots are populated and your summary statistics are generated in just one click. With panels, this way you won't waste time recreating your multi-tube analysis every time you run an experiment. So panels are really useful for clinical research and pharma labs. And what we'll do before we get started building a panel and loading it and learning how to modify it and batch process the results externally to PowerPoint, Excel, etc. We'll look at a couple examples of panels so you'll see the different situations in which they might be useful to you. And again, if you have any questions, just feel free to type those in and we'll address them as we go. So the first layout I would like to show you is this is an antibody testing layout, and it's a panel that consists of 3 tubes. So remember, panels are really useful for multi-tube experiments where you have a number of iterations or a number of groups of files, and each group of files can contain anywhere from typically, 2 to as many as 10, 12, as many tubes as you need. So in this example, we've got 3 tubes per panel. And since this is an antibody testing layout, we have an isotype control, which we see here in the histogram that I'm highlighting in the shaded gray. We have a positive control, which is the black histogram, and the experimental sample antibody, which is the red overlay. Okay, and we also have put in some interesting statistics here on our layout, such as the sample to isotype control fluorescence ratio, which in this case is 1.24. So I can go to my next group of 3 files, which is testing out the sample B experimental antibody and its matched isotype and positive controls by clicking next here on the data tab. And you see that the histogram overlay is updated, and we also have the sample isotype control fluorescence ratio updated to 3. Okay, so hopefully you can see that this is a much more efficient and informative analysis than if you were to just look at your files on a one-by-one basis, i.e. just looking at the isotype and then the positive and then the experimental and then somehow having to wade through all those statistics in Excel and get out the salient statistics that you need. So in this case, the key points are here on the layout itself. So you've got that fluorescence ratio, and you can easily batch process through multiple files. You could be testing, a whole 96-well plate of experimental antibodies here, and just in a couple of clicks, you'd see your summary stats. Okay, so that's one example. Another example here is this is a mouse experiment where 3 tubes were acquired per mouse. So in this example, we have 3 mice. So you can see in the data list here, which I'll circle, we've got 3 mice, and in alternating groups of gray and white, you can see that each mouse has 3 different tubes. So each mouse has a T cell tube, an NK cell tube, and a B cell tube. And we have a few different plots here on the page, as well as interesting summary statistics, including a CD4-CD8 ratio. You could have multiple pages here. This is just a simple experiment where we just have one page on our FCS Express layout. But if you wanted to, you could analyze the T cell tube on its own page, the NK cell tube on its own page, and so on. It's really unlimited what you want to do. But again, the key point is I can press next and previous to advance through my data list or my batch of files. Okay, and you can see that all of the statistics and the plots are updating as I go. And if I needed to, of course, I could just change the stats, change the quadrant and gate positions if I wanted to for each iteration. Okay, and if I wanted to summarize all of these, I do have a couple of batch actions already lined up for this panel, which is a PowerPoint export and an Excel export. And we won't be talking about in detail how to set these up because we do have a webinar that covers all the details of batch processing. And we also go over the main points of batch processing in our Get It Started webinar. But what I'll do is I'll just run that batch process real quick. And then you'll see how quickly you can summarize the results externally when you use this panels feature in FCS Express. Okay, so here is the summary in PowerPoint, where this is our first mouse, mouse 1, and you can see the 3 tubes and the summary stats. And I go to the next slide, and then that's mouse 2, and the next slide there we have our mouse 3. And we also generated an Excel export, which I believe I can show you right here. Here it is. Okay, so we have 3 rows of data because we had 3 mice, and then all of the statistics that we chose to export to Excel are here as well. Okay. So let's close that out. I'm going to show you a couple more examples. This is an example of a panel that was saved unlinked. You can see that it comes up empty. So by unlinked, I mean that the panel is saved as an empty template to facilitate loading in the day's files every time you open up the layout. So what I'm going to do is navigate to the files from today that I'd like to load into this unlinked panel. And we will go over how to save a panel linked versus unlinked. And again, this is a clinical panel. The other 2 layouts I showed you were more research oriented, but this is the type of panel you might see in a lab that tests multitudes of patient files every day. So, and this is a very complex panel. So you can see in the bottom left corner here that we have 10 pages in the layout. So I'm highlighting that down here. And you can notice that the number of pages need not correspond on a one-to-one basis to the number of tubes. So we have 5 tubes in this panel. So a B cell tube, a blast tube, monotube, T cell tube, and a viability tube. You can see from the data list. So that's only 5 tubes. But the author of this panel chose to create 10 pages in the layout. And we can actually scroll through them and see how complicated and large this panel is, but you see that all the plots and all the statistics were generated just in a matter of seconds. So that's the power of a panel for you. Okay, and if I had another group of another complement of patient files, I could load these in here and batch process through that as well. Although typically in a clinical lab, you usually look at one patient at a time. And let's show you another example before we get started. Okay, so this is kind of a fancy one. And again, this was saved unlinked. So what I'll do is I'll just load this up with the files that go with it. So this is a panel of 8 tubes, and this is a T-cell spectrotyping experiment. Don't need to really know the details, but basically it is an experiment that's evaluating the diversity of the T cell receptors in this tube. So, and on the right, we have a bar plot, which are very easy to make in FCS Express 5, by the way. And you can see the diversity of V beta isoforms for the T cell receptor here on the x-axis. So we have quite a few different populations here. If I move this T cell gate onto the T cell dim population, you can see that we actually have, a rather clonal population where this clone dominates. So the key point here is this is a very interesting, complicated layout that might have taken a little bit of effort to set up initially. And using panels, you can reuse this layout over and over again. So all of the elements, including the bar plot and any other sophisticated reporting graphs you'd want to put in, will be included in the panel. Okay, so do any of you have any questions about those layouts that we've showed you so far? If you do have any questions, for those of you who have joined us a little bit late, feel free to enter those here in the enter a question for staff box, and either I or Sean will get back to you during the course of the webinar. Okay, well, if there are no questions, let's go ahead and get started. So this should look fairly familiar to you. This is that mouse panel, or that mouse layout that we talked about earlier, where we have 3 tubes per mouse, and we want to sort of batch through the multiple mice on a 3x3 basis, because we have a T cell tube, an NK cell tube, or a B cell tube for a total of 3 tubes. So let's finish building this layout before we convert it into a panel. And that's a really key point. So when you are making a panel, what you want to do is you want to just build the layout normally as you would. So there's nothing special you have to do really to use the panels feature when you're initially building your layout. So let's continue building this. It looks like we just need one more plot. So we have an NK cell plot, a T cell plot, and we don't have a B cell plot yet. So let's put that in. And when you're building a panel, it's a good idea to start with just one group of files in the data list. So you can see I only have the files from mouse 1. That'll make it less confusing, so you won't risk mixing up the files from mouse 1 with mouse 2. So just start with one complement of files in the data list when you're initially building your panel. So this is just a normal layout, and I'm just adding one more plot here to look at my B cell tube. Okay, and let's look at CD19 here. Okay. And we could probably gate this on lengths. And let's just draw a gate here. And we'll call this our B cell tubes. And I do see a question coming in about working with an empty template. You can certainly start building a panel from a completely empty template, i.e. a blank page. And in fact, that is how most panels are built. We're not starting from the absolute beginning there just because some of those things like inserting plots and creating statistics are things we cover in other webinars, but absolutely, we encourage you to do that. So there we go. Okay, and let's go ahead and put that statistic into our cell to complete the table. There we go. So you can see that that's going to update as I move that around, of course. So now our layout is complete. So let's hit save. So once you're happy with your layout, you're ready to convert it into a panel. And there's a couple of different ways to do that, or a couple different ways to reach the panels feature rather. So one of them is here on the data tab, and I'll just point that out. So here on the Data tab, right beside the data list, should be easy to find, we have this Panels feature. And you can also find it anytime down here at the navigation toolbar where it says no panel is active. All right, so let's go ahead and convert this into a panel of 3 tubes. So I'm going to click Add, and here is where you can give that a name. So I'll call this my mouse experiment. And the number of tubes is 3. I can see that in my data list. And it's recommended that you give each tube a descriptive name. Although it's not required, it is recommended because it will help you keep your tubes in the correct order as you add the subsequent mice or subsequent patients, whatever it is that you're doing. So let's go ahead and give these tubes a name, and I'm just going to follow the order as it exists in my data list currently. And these names can be rather short, just enough for you to know the basics of what you're doing here. All right, so I'll click OK one more time. And now if we look at our data list, you see that we have the same 3 tubes, the same 3 FCS files, but they've been assigned to specifically named tubes in the panel. So the T tube, the NK tube, and the B tube. Okay, so we're technically done here. We've built our panel. I could save, close, and reopen this layout and reuse it over and over again, and we'd be done. But the main point of building a panel is really to reuse it over and over again. So what I'm going to show you is how we can add in the next group of files from mice 2 and 3, and then we'll show you how to save the panel. Well, we'll show you how to modify it and then save it either linked or unlinked and reopen it. Okay, so we have our mouse 1 files in here. I'm going to add in my mouse 2 and mouse 3 files. Okay, here they are. So you can see that when you add in the files, they come in alphanumeric order or reverse alphanumeric order. So in a lot of cases, that's not going to be correct. So you can reorder these files really easily. One way is to use the sort function. So if you have multiple keywords in the data list, you could use the sort function, and that would help you sort by keyword. So if you have a sample type keyword, or like a mouse name keyword or a patient name keyword or something like that, that could probably help you. But in most cases, you may not have those, so it's easy to just reorder them manually. One way is using these blue up and down arrows, so I can just match my T cell tube with the T cell tube. Now I'm going to grab my NK cell tube from mouse 1 and move that up to the appropriate place. Okay, you could even do multiple files at once. So I could do a control click and move both of these 2 up at the same time. Another thing you can do is move this B cells tube up just by dragging and dropping. All right, so let's just get these in the correct order. And notice as I'm doing this, you can see that if I move the first iteration, which is currently showing on the layout, if I move it up and down, you can notice that the plots are updating, right? So the files are being set to different plots depending on how I order this. Okay, you can take a look at the first and third plots there changing. All right. Almost done here. Okay, great. So everything looks like it's in the correct order. So I'm going to hit save. And so now I can click next, and you can see that we're efficiently batching through our files on a 3x3 basis. So this is the mouse 2 files. Okay, this is the mouse 3 files. All right, and once your panel is built, you can feel free to modify the panel. Like I said, this was built initially as a simple layout with just 1 page, but I can look at 2 pages if I want to. And let's say I want to look at another couple of plots with my NK cell tube. So I can just drag that out here. Let's say I want to look at, maybe this time, a color dot. Okay, anything at all you wanted to do. You can even drag, draw new gates at this point. Okay, so I have multiple pages, multiple things going on here. Okay, so we can even put in some more plots down here. And the reason I'm doing this is just to show you that nothing is set in stone with your panel. It's very flexible and powerful. Okay. All right. So I can still go back and forth through my panel here, and you can see that the plots on both pages are updating very painlessly. Okay, and so I could set up a batch process if I wanted to. We're not going to really go into a lot of detail, but just to drive the point home, let's just set up a real quick one here. Okay, we'll just put in, let's say, a PDF. And we can do all pages. And I'll just send this to my desktop. Okay. So now we can click Run, and we'll see that that's going to be generated very quickly. So here is our PDF, and this is a 6-page PDF since we had 2 pages in our FCS Express layout and 3 mice, so that makes for a total of 6 pages. So here's the mouse 1, page 1. And now I'm going to go to the second page, so that's the second page for the mouse 1. And here's mouse 2, and here's the second page for the mouse 2, and so on. Okay? So let's show you, we already saw so far how to create the panel and load the panel and modify it and batch process it. So let's show you how to reuse this panel. So as I mentioned, I could just save this and close it and reopen it and delete out all the files and add in a new group of files. That's fairly straightforward, and you probably do that with some of your existing layouts, whether they're panels or not. But what I'll show you today is how you can save it unlinked, like we demonstrated at the beginning. Just looks like I didn't quite get that. So let's call this mouse panel unlinked. Okay, now I'm going to close it and reopen it. So you see that these come up as empty plots. It's essentially a template that we can load our files into. So we'll just navigate via the data list. Let's say we only had 2 mice this time, so I'm going to just select these files. Okay, and really all you'll have to do at this point is reorder the files so that they match up the tube names. Again, you can notice the plots updating as I'm doing that. Okay, so this looks just about done. So I can advance through my data set, and you see all the plots are updating, and we basically recreated our entire analysis in a matter of seconds rather than starting over from scratch. Okay, so that is working with panels in a nutshell. Do any of you have any questions about what we've shown you? If you do, feel free to enter them into that questions and answer screen, which is right here where it says enter a question for staff. All right, well, if there are no questions, thank you so much for joining us. Hopefully you've seen that panels will help you automate data analysis for repetitive experiments. They're very easy to create, load, and modify, and you can combine them with batch processing actions. So all of that combined, plus the ability to easily reuse panels, should make it very easy for you to analyze your multi-tube experiments in an efficient manner. So if any of you have any questions, we'd be happy to help any of you out to use panels, whether you're using FCS Express 5, a purchased license, or the demo, or even if some of you are using FCS Express 4 or older versions, we're happy to field your questions. You can feel free to email us at support@denovosoftware.com. We have a bunch of other resources which are available on our website, and they're also easily accessible from our startup screen. So if you download the demo of FCS Express 5 from fcsexpress.com or denovosoftware.com, you'll be able to see the startup screen once you launch it, and then you can click on any of these squares to get more information. So if you click on support, it will take you to our support website, where you can email us or give us a call or request on-site help or live help via screen share or a phone call, where we can help you out with your own layout. And the demo is here, by the way, if you wanted to download the demo. And there's also this handy bank of videos here under Video Guide. And I believe there is a short video there all about panels. It's only about 3 minutes long, and it'll take you through most of the points that we made in working with panels in today's extended webinar. This webinar will be online, and once it is posted online, you will receive a link. I see one question. What is the difference between a panel and a template? That's a good question. So a template just means a layout that you reuse over and over again. And so that can be a panel layout, i.e. a layout that you've created to process multiple files for like a multi-tube experiment. So where you have a patient that has like a B cell tube, a T cell tube, and a monos tube, for example. But a template can also be a non-panel layout. So let's say you're just analyzing a stack of 96 well plates, and you're just going through the wells on a one-by-one basis to see which one is a hit. That would be an example of something you wouldn't necessarily need a panel for, because you're really just looking at files on a one-by-one basis. They're not really occurring in groups of 3 or 5. But they're both templates in the sense that you reuse them. Okay, so you can save either of those unlinked, i.e. with the empty plots. That's a popular way to use templates. But you can also just save them linked, and in that case, they'll come out with your old files from the last time that you analyzed the experiment. And you would just have to kick out those old files with the red X on the data list here. And then you could put in the new files. Okay, so if you have any questions about what is the best way to go about your particular analysis, feel free to email us and we'll follow up with you offline. We're happy to advise you. Okay, well, if there are no other questions, thanks again for joining us, and we hope to see you next time.